Good morning.
Good morning, sir.
Good morning, sir.
Morning, sir.
Good morning.
Yes, come. How are you?
Morning, sir.
How are you?
Sir, please, we are fine.
We are good, sir.
How about you?
We are also good. By God's grace. I
We
did.
thank God.
So I hope you are hearing me, right?
Yes, please.
Okay, so if you can hear me, that's good. I think you've been on this class, right? That's a week ago.
Sir, please come again.
I sent you a video concerning this class about a week ago.
Yes, sir.
So please, some of us couldn't watch it though. It's not when you try opening it, doesn't come.
Some of you didn't go.
That version is not.
Don't you have a Google Drive?
She should say she couldn't watch it using the some of us.
Okay, no problem. She didn't watch it. That's okay. Okay, so I think we can start the class today, right?
Sir, please, there is echoing in your voice.
Yes.
Oh, okay. Then let me see how best I will solve this.
Meine Mutter spielt nie Klavier. Meine Mutter spielt nie Klavier.
The verdict is absolutely. Congratulations to all.
Back from the inside everybody. Whether you are ineffective or whatever you're doing, would you chop masters or whatever? Recognize.
Come on, catch up. I'll review for la femme.
When that we are working with that. When you come there.
As begins, mute yourself. Why? Abba.
Then I said, tell them He has not even handed over to her. Wow. Political appointment.
I don't want to hear your handing over. Please mute yourself.
When she just get up, she will bath and wear. She's going to work and she will just come out to plan and go work. That the bed bath and not have to.
Madam Regina Kofi, you are disturbing.
Bamikro, I don't understand this. Are we kids? We are not kids. Abba, let's behave. What kind of behaviors is that?
Hello? Can you guys hear me? Can you guys hear me?
Yes, sir.
There's noise. People in the market. When they leave the market. If you are in the market, mute yourself. Eh?
Hello, please can you hear me?
Yes, sir. We can hear you.
Sir.
Is it very clear?
It's breaking.
It's clear.
It's breaking.
Yes, sir.
Say, look as if you are far from the phone. I don't know, dear.
Okay, let me see what I can do. Now, let's go. But I'm going to please, I'm giving you some few minutes. I want to try with my laptop. It seems this place, the machine that I'm using is giving me feedback. Or if it is clear for you, is it clear?
Okay, sir. Sir, please, not all that clear.
Okay, so sorry about that. Now I think everything is clear, right? You can hear me very well, right?
Yes, sir.
Okay, that's good. That's good. So we've missed some time, so let's quickly start what is expected of us today. So today, what we are going to do is what we refer to as correlation. Correlation. So correlation means relationship between two things or two variables. So for this, we are going to know how to determine if there exists a relationship between two quantitative variables or two metric variables or two numeric variables. Okay, so basically that's what we are to do today. That's what we are going to do today, where at the end of the day, you will know the differences. You will know if there exists a relationship between two variables. Okay, so I've given some examples or scenarios where we can apply it. So I'm saying that a medical researcher is interested in questions such as caffeine related to heart damage, and want to can know if there's any relationship between age and his or her blood pressure. So these are some of the scenarios, but it doesn't mean that this thing is exhaustive. Okay. So in determining your relationship or the correlation between these two variables or between two variables of interest, you should know what we call the dependent variable and the independent variable. And then you guys remember I told you guys that the dependent variable is most cases is always represented as y and then the independent as x. Okay, so before you even compute or know the strength of that relationship, there's something we call the scatter plot. The scatter plot. The scatter plot will tell you the type of relationship between these two variables. The scatter plot will always tell you the type of relationship between these two variables. It will not, keep in mind here, it will not tell you the strength of that relationship. It only gives you the type of that relationship, but it will not give you the strength of that relationship. That's what the scatter plot does. It only gives you the type, but not the strength. So one can ask, say, then how then do we plot, or how then do we get this scatter plot? So you can always plot it as usual, as we normally. So let's pick one example here. Let's look at this example. We want to know if the number of absences that you come to my class is going to affect your grade. So if you look at this one, these variables, we have the number of absences and then the final grade that the person will get or the person had in the exam. So if you look at this scenario, as a researcher, you should know that it is the number of absences that is going to affect your final grade. There's no way your final grade will affect the number of absences that you have. Okay. Did you get my point? So if that is the case, then the number of absences will definitely be the independent variable, and then the number of and then the final grade will now be the dependent variable. Okay. So now let's continue. So the first thing that you can do to determine the kind of relationship is to draw your scatter plot. So we can draw the scatter plot. I'm going to draw it here. So I will label this thing as Y, and I'll label here as X. Okay, because I don't have, it doesn't matter if you want to, the scale, you choose your scale. As a researcher, you choose your scale. It doesn't matter. Depends on how you want to choose it. So because I'm having limited space, I'm going by, let's say, the X's, the highest value is 5. So I'm going to, let's say, multiples of 4. I can write here 4. I can come here and say 8. I can write 12 here. This is 12. Then I bring here 16. It doesn't matter. It doesn't matter. One person too can choose to, go by 1, 2, 3. Okay, let me do something here. One person too, another person too can say that I'm not going by 1, 2, 3. I'm not going by 4. I can go by 2, 4. Shige, Ebue, Idia. You can go 2, 4, 6, 8, 10, so on and so forth. So it doesn't matter. It depends on you, what you want to do, okay? But because I'm having limited space, I'm going by the 4. So I'm saying 4, 8, 12, and I'm saying 16 here. Then here too, if I go through, I can go by tens. I can say 10, 20, 30, 40, 50, 60, 70, 80, 90, 90, I can say 100 here. And I'll bring my Y here. Okay. So if I have this, what I will do is I'll pick the first one. So how many observations do I have for this? What is the sample size for this? 1, 2, 3, 4, 5, 6, 7. So that means N is equal to what? 7. Okay. So if you look at this, now I'm to draw the scatter plot. The scatter plot, you draw it as you see it. So this is 682. So I'm assuming that the 6 is here, 6 is here, and 82 should be somewhere here. So 6, this is where I can find my 6, and 82 is somewhere here. So I can put the point here. Okay. Here, the next one is 286. My 2 is somewhere here. And 86, I'm assuming that 1, 2 is here. Okay. The next one is 1543. 15, I'm saying 15 is here. And then 40, this is 40. So 43 should be here. So I'm pointing it here. The next one, 974. 8 is here. I'm expecting 9 to be somewhere here. 9 and 70 is here. So I'll point it somewhere here. Okay. The next is 1258. So to have 12 here, 58 should be somewhere here. The next one, 590. So 5 is here. 90 should be somewhere here. Okay. The next 878. So 870. So 78 should be somewhere. Let me put it here. Okay, so this will be the scatter plot. This will be the scatter plot. And as long as the points are behaving something like this, you see the points are behaving something like this, then it tells you that there is a negative correlation. There is a negative correlation. A negative correlation means that whenever this X is increasing, the Y is decreasing. Again, whenever I say negative correlation, it means that if S is increasing, Y is decreasing. So you realize that this time around, when the number of absence is increasing, the final grade is decreasing. The more you absent yourself in class, the less mark that you get. That is what this graph is telling us. Okay, but it is not telling us the strength of that relationship. So what I'm going to do is I'm moving on to the actual graph so that you appreciate that one. So this is the actual graph. Do you get it? So once the graph is behaving like this, you see this one I use 1, 2, 3, 4, 5, 6, 7, it doesn't, so, and then the other one I used 10, so on and forth. So this I started from 30 because the small one, the less one in the Y's, I had 30 to be the least one. Okay, if you look here, 30, if you look here, the least one is 43, so I don't have 20, that's why there's 30. Okay, so if you plot, it is behaving like this. And once the graph is behaving like this, it tells you that there is a negative correlation between these two variables. That's Y and X. So you would tell us what Y represents and you would tell us what X represents. Okay, so that is how the scatter plot will tell you. So the scatter plot will give you idea. It gives you an idea about the kind of relationship. It doesn't tell you what actually the relationship is. Do you get my point? So that is what the scatter plot tells us. It tells us the kind of relationship. It tells us the kind of relationship. It is not telling us the strength of that relationship. So if you look at this one, it's giving us that there is negative correlation. And so you find out that when we compute the correlation coefficient for this data set, you get a negative answer. The correlation coefficient for this data set will give us a negative answer. And the answer is likely to be around 0.8, 0.9, because these things, the points are almost in a line 4. And so once the points are almost in a line or in a linear 4, then the strong the correlation is. Okay. Okay, so now let's move on it's likely we will revisit the scatter plot. Okay, so in order to determine the strength of that relationship, in order to determine the strength of that relationship, you will use what we call the correlation coefficient. In order to determine the strength of that relationship, in order to determine the strength of that the relationship, it is the use of correlation coefficient. We use correlation coefficient to determine the strength and the type of that relationship. You know, I said that the scatter plot just tells you the kind of relationship. It doesn't give you the strength, but the correlation coefficient gives the strength and the type of that relationship. Okay. And if you compute the correlation coefficient, it always lies between -1 to +1. It always lies from -1 to +1. That means you can get -1 and you can get +1. So the values from -1 to 1, these are the answers that you should get for correlation coefficient. If you get anything outside this value, then that means that there's something wrong. You're not doing the right thing. Okay, so if you get exactly +1, then that's where we will say that there's a strong positive correlation, which is 1 out of 1,000, and then perfect correlation. That's what we refer perfect correlation. Perfect correlation. And when there is -1 as answer, we will say perfect negative correlation. And so now someone will ask, how do we compute the correlation coefficient? So I think there was a hand up. Okay, the hand is down. Let's continue. So the correlation coefficient is giving us this formula. The correlation coefficient is giving us this formula. This is what we use to compute the correlation coefficient. Okay, let me land. When I land, I'll permit you to talk. When I land, I'll permit you to talk, okay? So the formula for computing correlation coefficient is giving us that R normally represent the correlation coefficient as R. And R is giving us N multiplying summation XY minus summation X multiplying summation Y divided by the square root of N multiplying summation X squared minus summation X all squared, all multiplied by N summation Y squared minus summation Y squared. Okay? So this is the formula to compute the correlation coefficient. And please keep in mind, the more you get closer to 1 being positive or negative, the strong the correlation is. The more you get closer to 1, either being positive or negative, the strong the correlation is. And the more you move away from 1, or the more you go closer to 0, the weaker the correlation is. When you get 0, there's no correlation. They are not related at all. Okay? They are not related at all. They are not related at all. Okay, so let me permit Anita to ask the question. Anita, you can ask your question. Anita, ask your question.
Hello, sir.
Yes.
Thank you. My question has to do with the scatter plot. You were saying that as X increases, I didn't get the plotting well, because the axis X and Y, when you plot the percentages on, I don't know.
Anita, unmute yourself and talk.
Hello, sir.
Yes.
Yeah. The scatter plot. I don't know which one is rising and which one is descending. Please, can you take that again?
Okay.
Yeah.
Okay. So what I'm saying is, whenever you plot and this plot tells you that there is a negative correlation. Okay. So if you look at this point, let's play this point. Anita, what do you think S value will be? Wow, she's not there. Okay, let me take it back to the data.
Sir, please, 15.
Okay, so S is 15. And then Y valued what? Definitely Y will be 40.
Yes, please.
Okay. So now, that means that the S is 15 and Y is 40. Okay, now let's go back. Let's come to this point. This point, what is the value? S is what? 12.
Yeah.
And then Y is what?
60.
60. Now when you are here, N is what? 9.
9.
And then Y is what?
70.
Okay, now I'm here. S is what? S is what?
8.
8.
And then Y is what?
80.
Okay. And so now this time around, I'm here. S is what? 6. And then Y is what?
8.
Y is it 6. So you can see that. You can observe that. You can observe that as the X increase in value, the Y is decreasing in value. Please, can you see that?
Yes, sir.
So that's what I meant. And that is what we imply by a negative correlation. A negative correlation means that, okay, let me draw a line for you to just, if I draw a line like this, if I draw a line like this, if I'm here, 1, if I'm 90, 90, the corresponding value will be 1. If I'm 80, the corresponding value will be 4. If I'm 70, that is 7. If I'm 60, I didn't draw it properly, but I think it's okay. 60, 50, let me bring it here. 40 here, and let me say 30 here. So you see that as 90, you see as S is increasing, Y is decreasing. Do you get it?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
So that is what we meant by the negative correlation. So negative correlation, always the graph will behave like this. If you draw a circle around it, it should behave like this. And if it is a positive correlation, the graph behaves something like this. And so that one for positive correlation, when S is increasing, Y is also increasing. That means there's a positive correlation. For positive correlation, when S is increasing, Y is also increasing. Okay, I have examples there. So let's continue as we move on, and you should get that one too. Okay, I hope I've answered you. Move on. Okay, let's move on. Now, so I've already shown you the formula for computing the correlation coefficient, which will give us the strength and then the type of the relationship. So this is a sketch of the scatter plot and its respective correlation coefficient. So if you look at this one, As I indicated earlier on, if I'm to draw, you see that it's behaving like this. Even if I'm to draw a line towards them or through them, it's behaving like this. And that one, that is the reason why we are getting a correlation coefficient of +5. So that tells you that there is a positive correlation, and that implies that as S is increasing, Y is also increasing. There is a positive correlation, okay? And keep in mind that if you compare A and B, you will see that B is having a strong correlation because the correlation coefficient is 0.9. I can say that there's a strong correlation. You can see that if you compare A and B, you see that B points are more getting closer. They are almost getting in line. They are getting in a line form than A. You see that A, they are moving a bit away and they are not almost in line. But if you compare B to A, B is much linear as compared to A. That is why the correlation coefficient here is bigger than that of A. And if you compare A, B, C, you see that C has 8 points in a line form. And you see that I'm having a correlation coefficient of 1. So the more you see your points, the more you get your points in a line form, the stronger the correlation is. And so that's why I told you that the scatter plot will give you the idea about the kind of relationship, but it doesn't give you the strength. But if you practice, you know that it gives you an even idea about the strength. It gives you an idea about the strength. Okay. And so that is what the scatter plot is telling us with regards to this positive correlation. So now let's go on to the negative correlation. And also, this is also negative correlation. You see that this one too is moving towards the left-hand side. See, as I drew earlier on, this is negative correlation, negative correlation, negative correlation. Okay. Any questions so far before we start with the computations? Any questions so far? Please, if you have any question, please talk to me before I start with the calculations. All right, please talk to me. Oh, Mariam, Olivia, Abdullah, you talk. Okay.
Sir, please. Hello.
I'm listening.
Please, sir, I didn't understand the positive correlation.
But you're okay with the negative?
Yes, please.
So what did I say the negative is? Oh, Belinda, you talk again. What did I say the negative is?
So I was muted. Sir, please, you said with the negative, the scatter plot was plotted directly to the left.
Oh, that's not what I said. Can someone help? Can someone help? Those who want to help, you can unmute yourself and talk. Is it Bridget? You can unmute yourself and talk. Oh, okay.
Sir.
Yes.
Hello, sir. This is Bridget.
With the negative correlation, you said whenever X is increasing, then Y is decreasing.
Okay, exactly. And so can we also help her with the positive?
So the positive is the opposite of the negative. So when Y is increasing, X is decreasing.
No. That's not what I said. Y, you see, Y can never have impact on X. You know, Y is the dependent variable, right? It's always Y depending on X. Do you get it?
Sorry.
It is always Y depending on X. So come again. You get it. You have it, but you have the
So,
idea.
with the positive correlation, when X is decreasing, Y is increasing.
When S is decreasing, Y is what?
Increasing.
No.
Sir, you said with the positive, when Y is increasing, X is also increasing.
Exactly. On the other hand, exactly.
On the other hand, when Y is decreasing, X will also decrease.
No, I said Y doesn't have any impact on X.
Okay.
Y can never change. Y is always depending on X. Please, I hope it's clear.
Yes.
So let me just illustrate it here. See, for this one, I want to go to the positive, Y, the positive. This is positive correlation. So let me just draw a line here like this. Let me draw a line from here. And let's assume I have 1, 2, 3, 4. And I have 2, 4, 6, 8 here. And so if, let's say S is 1, right? You see that it's likely I get 2. If S is 2, you see that I'm going to get 4. If S is 3, I'm going to get 6. If S is 4, I'm going to get 8. You see that this one is increasing and Y is also increasing. Please, I hope it's clear. Hello? I hope it's clear.
Yes, please.
Okay. Any other question before I continue? Any other? Can I continue?
And sir, please, you said something that the more the points get closer, or the more you see the correlation in a line form, the stronger the what? I didn't get that part.
The stronger the correlation is. You see that this one, the points are in the line form. So you see that this one, the points are more or less in a linear form or in a line form. And so that is the reason why we are having a strong correlation coefficient. This one is telling us the correlation coefficient. Okay. So the more you get closer to 1, the stronger the correlation is. Okay. And then the less you move away from 1, the weaker the correlation is. Please, always clear.
Yes, sir.
Can I continue? I hope I can continue, right? I think now I can continue. Dorcas, Mensa, ask your question. Dorcas, Mensa, your hand is up. Ask your question.
Please, what about the zero relationship? No linear relationship for the zero.
What are you done?
So you said with the -1, when x is increasing, y is decreasing. And you also said that when it is +1, when s is increasing, y is also increasing, and the y doesn't have any impact on the s axis. I'm asking, what about the zero linear relationship? Do we have anything for that, or I don't
If
get
there's
that
no
one?
relationship, the graph may behave something like this. If there's no relationship, you see it somehow like this.
A minute.
Do you get it? You see that there's no any linear.
There's no direction.
Yeah, exactly. Do you get it? And so this will tell that there's no relationship between y and x. I hope it's clear.
Look at this. Is she having black?
I'm coming.
Is she having
orange?
Is she having African?
I hope it's clear. Patience, ask your question.
Hello, sir. Please, I want to be sure of this statement that I wrote down. For positive correlation, when the x is increasing, the y also increases. And then for the negative, when the x increases, the y decreases.
Exactly.
Okay, thank you, sir.
I think I can move on.
Yes, sir. Yes, please. You can go ahead.
Now let's move on to how to calculate the correlation coefficient. So now we are still going to use the example that the number of absences in a class and the final grade, and check how best we can estimate or how best we can compute our correlation coefficient. So the same formula, the same data. Okay, so this is the data, and then what will be n? N is what? What is the answer for n? N is what? So type the answer for me. I don't want anybody to talk. Type the answer. What is the value for n? Let me see. Okay, that's true. 7. That's okay. That's okay. So n is 7. The number of times that we observe it. So we are going to apply the formula. But if you look at the formula, the only thing that you as a researcher you will need to compute is this guy, summation x. Okay, let me just point this thing out. Summation s squared is not equal to summation x all squared, please. This is not equal to that. Summation s squared is not equal to summation x squared. Please take note of it. Summation x squared is not equal to summation x all squared. Please. Okay. Son, Iriba Vida, ask your question.
Sir,
Iriba Vida.
please, where did I get the 7 from? I'm confused.
7 is the sample size. And how do you compute the sample size? How do you identify it?
I'm not seeing the samples, Kra. I don't know.
Oh, okay, you are not seeing this. Okay, look at this one. Now you can see it.
Yes.
So now they are saying 7. Do you agree with them?
Unless I add and divide and see.
Unless you do what?
Or
This one you don't need to add and divide anything. You just have to
I'm
identify
going
it.
to count. 1, 2, 3, 4, 5, 6. Okay, I'm okay now, sir.
You're okay now. Okay, that's okay. Let's continue.
Yeah.
So if you look at this formula, the only thing that you need to do, you would need to compute summation x squared, and then you will need to compute summation y squared, and then you will need to compute summation xy. Because the data will always contain x and y. Always you get x and y. And so if you have x and y, you sum everything, and then you get summation x. You sum everything, you get summation y. If you square summation x, then you get this value. If you square, sorry, summation y, you get this, summation s, you get this. So the only thing that you will need to compute will be these three guys. These three guys, summation xy, summation s squared, and summation y squared. These are the three things that you need to compute, okay? So now let's go and compute the correlation coefficient for our work. Now, let's write it. Okay, this is the data set. This is the data set. I hope it's clear. So now you will need to compute summation xy, we need to compute s squared, we need to compute y squared. So the x and y we were given, these values were given, these ones were given to us. So now we will need to compute our xy. And how do we get sy? Sy means we are going to multiply this and that. Okay? Sy means you are multiplying the x and y's. So I'll multiply this and that will give me this answer. I'll multiply this and that gives me this answer. I multiply this and that, it gives me this answer. I multiply this and that, I have this answer. I'll multiply this and that, I get this answer. The next is the same thing, is equal to that. Then the last one, this, I get that. Okay, and that will give me my x and y, sy. That will give me xy. Now the next is to compute our x squared, s squared. So s squared, we know our xy. We know how we arrive at sy, okay? Okay, I'm going back that, so we know how we got our xy. So if we want x squared, it means that it is x. Okay, patient Deborah, ask your question. Patience, Dubara, ask your question.
I don't understand why the y is. Hello.
Yes.
I said I don't understand why the y is into brackets percentage.
Please, it's coming from the data. It's coming from the data. Final grade y percentage.
Okay. Okay.
I hope it's clear now.
Yes, sir.
Okay, so let's continue. So now we have to find s squared. This is not the first time of you computing s squared. So S squared means I'm multiplying the number by itself, right? So 6 times 6. And that will give me what? That is giving me 36. 2 times 2, the number multiplying itself, it gives me that. 15 times 15, it gives me that. 9 times 9, it gives me that. 12 times 12, that also gives me 144. 5 times 5, 25. 8 times 8, 64. Okay, so I'm now done with this S squared. Now the next is to go and do Y squared. So the same thing that I did for X, I'm going to do the same thing for Y. So it means that I'm going to multiply 82 by itself. That's 82 times 82. I get 6724. 86 times 86. I get 7,396. 43 times 43, 1849. Then 74 times 74 gives me this. 58 times 58 gives me that. 90 times 90 is equal to that. 78 times 78 is equal to that. Okay, so that is how you compute your Y squared and then S squared. So the moment you have your X's, your Y's, XY, S squared, Y squared. Then the next thing is to sum so that you can get your various summations. So if I sum all these X's, it gives me the answer summation X. If I sum all these Y's, it gives me the answer summation Y. The next one, if I sum all these XY's, it gives me the answer for summation XY. If I sum all the X squared, it gives me the answer summation X squared. If I sum all the Y squared, it gives me the answer summation Y squared. Okay, please, any questions so far before we go and put it in the formula and compute the R square? If you have any question so far, talk to me before we move on. Raise up your hand. If you have any question, Bridget, connect you, unmute yourself and talk. Connect, do talk. Okay, I think she's not ready. Konadu is not ready to talk, so. And I don't have any other hand. Okay, so let's continue.
Hello, sir. I was unable to unmute. Please, my question is, in case this appears in an exam, are we to make this table as well?
That one day, I don't know. I don't know.
Okay, thank you.
It depends on you.
Yes, sir. Thank you.
Now, if you don't do this table, how are you going to get the summation X, summation Y, summation XY, summation S squared, and summation Y squared? How are you going to get it?
Maybe others would prefer to do a rough work on the side and then just put it in.
On this rough work, you do it on thing and then that's it.
Okay, thank you.
Okay. Okay, so no questions so far. Let's continue. So now that we know the values of summation X, summation Y, summation XY, X squared, and Y squared, we can just put them in the formula here. You see? Let me try and see if I can drawing these two so large you can see them. Now I want you to concentrate on the one on the left-hand side. I don't know how, I wanted to share two screens at the same time. I can't do that. Let me just go back. So now the formula is giving us that. This is the formula, please. This is the formula. And so we have to go and look out for n. And what is n? You rightly said 7. That's why we have 7 here. And then now the next is summation xy. Summation xy. What did we get? We had xy is 3745. And so if we put it in the formula, that's why we have 3745. Now you want summation x multiplying summation y. So we just go and put the value of summation x, 57, and then multiply it by summation y, which is 511. So let's put it in the formula. That's why we have 57,511 here. Okay. Now divided by, you see there is still n here. We still have n there. There's still n. So that means that we still have 7 there. And then we should get summation x squared. Summation x squared is what? 579. So we have 579 minus summation x squared. So summation s, we had 57. We square it here. So this bracket also indicates that everything here is multiplying everything here. So it means that everything that I've underlined here is multiplying the one on the right-hand side. Okay, so this one too, you do the same thing for the y. Summation y squared, we had a value of 38,993 is here, 38,993. And that is what we have here, minus the summation y squared. Summation y is here, and the square is what? 2. So from here, the rest is very simple. But as I already informed you later, earlier when we were doing the, I think that was the t-test, I told you that, or was it the chi-square test? I told you guys that please don't rush, don't be in a hurry, don't try to give everything to the calculator. Please, I would advise you to take your time to do it one after the other. For example, this one, you multiply 7 by 3745, then you put the value there. Let's assume that one, you get a value A. You multiply this, whatever you get, let's say that one too is B. You multiply this, whatever you get, you put it there, multiply this, you square this, subtract whatever you get, you put it there, multiply this, you square, subtract whatever you get, you put it there, then you come and multiply whatever you get, you take square root of it before you do your subtraction and you divide. Okay, so you take your time and do this properly. The final answer is giving us minus 0.944. Minus 0.944. So if you remember, I told you that when we compute the correlation coefficient, we are likely to get something like 0.8 or 9 there. And the answer will be negative. So you see why we are getting negative correlation coefficient. And this tells you that we have a strong negative correlation. You see that the answer is negative 0.944. And this is implying that there is a strong negative correlation. So you see that the correlation coefficient has shown us the type of the correlation and also the strength of that correlation. I hope it's clear. Any question before we continue? Any question? Please, if you have any question, talk to me. Okay, Comfort Muruko. I don't know if I've mentioned it correctly. Comfort, ask your question. Okay, let me permit you to unmute yourself.
Okay, sir. Please, I want to know.
Oh, Comfort, sorry, unmute yourself again.
Sir, please, I want to know during the examination.
What?
11. Yeah, 11.
Sir. Please, I'm asking whether during examination the formulas will be given it to us.
But someone has asked this thing before. Please remember, I told you who asked this thing. Someone asked and I gave an answer. What did I tell you, class?
It won't be given.
I'm not going to give it. I don't know. I'm not going to give you the formula. Abubakar Zina, ask your question. Abubakar Zina, ask your question. Oh, Abubakar Zina, please ask your question.
Sir, I was still muted. Please, I wanted to find out if can still go over it again, please.
I can go over which one? Which one?
Just this formula, that's step 3.
Where you just put in the values or the calculations, I don't get it. Substituting the value or what?
Yes.
But that one, if you know how you computed the values, summation X, summation Y, summation X, Y, X squared, Y squared, you just replace them. Wherever you see X, Y, the value that you had for it, you put it there. Wherever you see Y, the value that you had for it, you just put it there. Okay. Wherever you see summation.
Thank you very much. So God willing, tomorrow we work on it, please.
Wherever you see summation X squared, you just put it there. So for this one, you are just replacing the values. You are just putting the value that you computed in there. I hope it's clear.
Okay, sir. Thank you.
Yeah. So the rest is just about multiplying and subtracting. But as I said, please don't try to do everything in the calculator once. Please. And when you finish, then you interpret your answer. This tells you that there's a strong negative correlation. And that implies that the more the student absents him or herself, the less mark that the person will get in the exam. Okay? Okay, Ajua, ask your question. Patience, Ajua.
Please, would the answers be given in a range? Because me, I had 0.9433.
0. what?
Negative 0.943.
0.943. So run it to the nearest. So run it to one there. So one decimal place will give us the same answer, right? So you are correct. You are correct. One decimal place is giving us the same answer. So it's correct, right? Ajua, are you there? Ajua, are you there? I hope I've answered you. Ajua, I hope I've answered you. One decimal place is given at it. So if you are getting 0.93, so it's the same thing. At the end of the day, we are getting 0.9. One decimal place, the same thing. Okay. I hope you are okay now. Now, another question. Vida. Please, there's also another one there which I expect you to try. This is another one which I expect you guys to try. All these things are, yes.
Please, I want to know at what figure will we say that is getting closer to 1 or away from 1?
Oh, okay. Okay, so some are saying that where is it? 0 to somehow some 0 point, let's say 0 0.1, 0.1. (0.1) to some say 0.3, 0.3. They will say there is a weak, or some even say 0.4, weak correlation, and from 0.5 to say 0.6. Some are saying moderate correlation, and from 0.7 to 1. Some are saying that there is a strong correlation. So it depends, be it positive or negative. Please take note of it.
Okay.
Yeah.
Yes, sir.
Any other? Anita Owusu Asante? Any other? Anita, do you have a question? Talk to me before I end the class.
Yes, sir.
There's
Okay.
also something I
Thank
want to
you, sir.
inform you about the exam.
So
Talk.
please, can we go back to the example you gave, the one we worked on? I want to ask you a question on the summation. I think most of us, we have this thought. We said we should go systematically.
Which one?
So I want to show you something.
This?
Yes, please.
Okay.
The first example,
Mm-hmm.
where the sample number was, yes. Please, where we substituted the numbers.
I did what? Which one? This one?
Yes, please. Where we substituted the numbers. Kindly show that one. Thank you. The my difficulty in computing the numbers are, you see that you said the 7. You multiply the 7 by 8,745.
Exactly.
Then you get a number minus 57. That one is times 511, right?
Yes.
You multiply the 7, the one in brackets times the 511.
Yes.
Okay, so when you come the over, is it the denominator? The one, yes.
Yeah.
Yes. Please.
You right
That
there,
one,
says so.
you see that the 7, you multiply the 7 by 569. Then minus
579.
Then minus the 57 square. Is it 57 times 57? Please, is it like
Exactly.
that? Okay. So when you finish, those values that you get will still be in a bracket form.
Exactly.
Okay, then you do same for the one on the right.
So exactly. So if you multiply this one, whatever you get here, let's assume the number is, let's say, I'm just assuming the number is, let's say, 3, right? And I multiply 57 by 57, let's assume the number is, let's say, 2. Then I come and subtract 2 from 3, I get 1. Don't forget it's still in a bracket. Okay? I come and do the same thing here. I do the same thing 7 times this, I get a number. I do this, and whatever I get here, let's say the number here too is, let's say, A. So it means that I'm going to multiply what I found here by what I found here. Okay? So whatever I get, I now come and take square root of that number. Then whatever I get for the square root, I can now come and divide for these ones. I hope it's clear. Please, is that clear? Class, now I'm talking to the class. Is that clear? Let me call someone to respond. No, since nobody is responding, please, if that is clear, you can type one for me.
Yes, sir. Yes, sir. It's clear. No, sir. Yes.
It's not clear. It's not
No,
clear.
sir. No, sir.
Please.
A question.
Okay.
No, sir, it's not clear.
Yes,
It's not
sir.
clear. It's not clear.
Okay. Hey. Nobody forced you to come here. Why you say it's not clear? Please, you don't do these things.
4, 3, 5,
Please, if you, please and please. I've been advising you guys. You don't react like that.
57.
You've not practiced. You are there, you don't take the calculator, work everything. You still want me to do these things for you. These things are just calculator. I'm not going to do that one for you. To be frank with you, I've explained it to you. I'm not going to multiply these things for you. Take your calculator, multiply it, and see if you are not getting it. I'm not going to do this thing for you, my dear sisters. I'm not going to do this. Multiply this for you, square this for you, subtract, get an answer, multiply this for you, square this, subtract, get an answer, and at the end of the day, multiply again. I'm not going to do that. Please try it. You take your calculator, people are doing it. So please try it. Grace, ask your question.
Sir, please. I don't know if I got you. We have the one with the square roots. You said we should add sum all of them up before we
I didn't say
put the
something.
answer under the square root.
I didn't talk about some. I didn't talk about some. Please, you listen to what I say. I didn't talk about some. I said you multiply it. You see that if I write A into bracket, this is a square bracket. A into bracket, B into bracket. What it means is A is multiplying B, A times B. That is it. And if I have A minus B, it means that B is B is subtracting A. Okay? So if I have, let me clear everything. So if I have square root of A and then B, it means that I'm going to multiply, this is the same thing as A times B. So if I have a value, let's say 2 let me clear everything. If I have a value 2 into bracket 3 in a bracket like this, and I say square root of 2 in a bracket 3 in a bracket, this is the same thing as the square root of 2 times 3. It's the same thing. And this is equal to square root of 6. Okay, so that is what I expect you to do here. You need to just take your calculator and work it out, please. It's not everything that I'm going to do it for you, please. These things, you have to do it. Please. Okay, any other question? If there's no any other question, let's work with the next example and then I'll end the class. If there's no question, let's work. I'm going to take you through there's also another example there, then I'm going to end the class. Okay? Okay, so let's take this example too. This one, we want to know the relationship between someone's age and then the weight of a child. Okay, so this is the data set. We have the age, and then we have that of the weight. Now the weight is Y and then the age is X. So the same procedure, you will need to go and compute XY and then get X squared and also get the Y squared. Okay. So if we are going through the same thing to get the X squared, Y squared, then, and also get the XY, the same procedure. We are going to multiply the X's by the Y's. So this time around to the same thing. This is going to multiply that. This will multiply that. This will multiply that. This multiply that, so on and so forth. Okay. Then I get my XY's. So when I'm done, I have to go and compute the S squared, which means that I'm going to square the 73, 65, 53, and that gives me the answers here. When I square 73, I'm getting 5329. I square 65, I'm getting 4225, the same thing. So you square these ones and you get that. And on the other hand, if you want that of the Y, you go through the same procedure. You square the Y's. So 16 squared, that means you are multiplying 16 by itself, and that gives me 256. 26 squared gives me 676. So I'll do it for all the observations. And if you look at this one, how many, what is the sample size? 1, 2, 3, 4, 5, 6, 7, 8. This time around, N is what? 8. So I just sum all these values. I sum and I get my various summation X, summation Y, summation XY, X squared, and summation Y squared. Okay. So the moment I'm able to get these guys, the rest is very simple. I just substitute them in the formula and I get my correlation coefficient. I just put it in the formula like this. I just put it in the formula. Okay. So after I put it in the formula, if you do it properly, like what we just did, we substitute the formula, the values in the formula. The final answer is giving us minus 0.16. And for this one, we can say that there is a weak. These are someone saying very weak. There's a weak relation between the variables. That's the age and the weight. That implies that as the person's age increases, the weight is decreasing. Okay. Okay, please, that is it for the day. If there's no question, let me inform you that. Do you have any question before I move on? Any question? Okay, so since nobody is talking, let me inform you, you guys, for your, wow, I just showed me. Let me stop sharing. Can I stop sharing? Can I stop sharing? Please, if there's no question, I'm going to stop. I'm going to stop sharing. I want to say something. Mavis, ask your question. Mavis, ask your question.
Sir, please, I want you to throw more light on the very weak and the weak. I didn't get that, please. Well, thank you.
Oh, I said that the numbers ranging from 0.1 to just say 0.4. Some are saying weak. From 0.5 to 0, from 0.4 upwards, 0.4 upwards to 0.6. Some say moderate. And then from 0.7 to 0.9, they are saying strong correlation. But as some also say very weak when they get closer to 0.1. This is very weak. And then when they get to, let's say, 0.9597, they say strong, very strong, very strong. They use those adjectives to just classify them. But at the end of the day, weak is weak. That's it.
Hey,
Evelina, ask your question.
Thank you, sir. Please, can you kindly show me the step 2? I'm writing on the question so that I'll solve it.
Oh, my dear, don't worry. You already have the slide, so don't worry. You can refer to it.
Okay, thank you.
Okay, so if that is all, I'm going to stop sharing, and then we have some few minutes to end the class. So I'm going to stop sharing, and then please next week. It's not likely I'll meet you next week. I'm not meeting you next week, but God willing, next week is likely we'll do the midterm where you are going to do it online. So that one will be online. That is going to be MCQs. So you go and do that one online. But for your end of semester exam, please take note of it. Your end of semester exam, you are going to answer all. Answer all. You are going to answer all questions. Okay, please keep in mind. You answer all questions. And then these, there's no MCQs. Let me just put it that way. There's no MCQs. There's no MCQs. You answer all, and it's going to take you 2 hours. 2 hours to complete the exam. There's no MCQs. You answer all. Okay? And I'm begging you, please and please, I'm begging you, make sure you are able. Please make sure you are able to compute your standard deviation and your mean before you come to the exam hall. Please, I'm begging you. Okay. So that is for your information. You are answering all. I think it's 5 questions. You answer all. Is it 5 or 4? Either 5 or 4. You answer all. And then there's no MCQs.
And we listen when they
Begin in 2 hours.
Sir, please, I didn't get the part that you said we should make sure we are able to compute our standard deviation and what.
It's okay. I won't repeat that one. I won't repeat it. I'll repeat myself, please.
standard deviation and mean.
Okay, so Matilda, and then if you ask your question.
Hello, sir.
Yes.
Please, the first day you were doing the standard deviation, I was not feeling well, so I didn't come. So I wanted to ask you if there is more time so that you take me through that one.
No, we have just 5 minutes, and I can't just take you only through that one. So I would advise that you talk to your colleagues, and if possible, refer to the lecture notes. I think I should get I should have a video on that one. But me teaching you only is not possible.
Okay, sir. Thank you.
I'll try and see if I have the video on that one, and probably I'll share with you. Or ask your class rep. I think I've shared a video on that one earlier. So try and get that video. Okay?
Okay, sir. Thank you.
Thank you, sir.
Okay. So, Anas, thank you very much for helping me control the class today. So see you guys, God willing, next 2 weeks or in the exam hall if I don't meet you again. So I'm down for the semester. I don't think I have to teach anything again. If you have anything, you can call me or send a message.
Hi, Casper.
We are doomed. I want to get something clear. The midterm, is it next week or next 2 weeks? Next week.
My dear, you know it. You know it. So it's likely to be next week or next 2 weeks. I will inform the class.
Be specific.
Sir,
do revision
please,
with
how many topics have you treated so far?
Hey, me, do I know? You are the student. You should know.
What do I know? That's so.
Yeah, please come
You
and do
said 5
revision with
questions
us.
on the exam. So each from each topic that you've taught
I said
us. So
5 or 4. That's what I said.
Please let it be 4. We are your sisters.
I said 5 or 4.
So, sir, if 5 or 4, one will come from standard deviation.
I don't know.
Or
That one I don't know.
test.
No, I don't know. I don't know about that. I don't know about that.
Sir, please, no, no, please, no.
Sir, please give us areas.
So it's time. So God willing, we'll meet next.
Areas, please.
And God be with us all. If there's no
sir, please, areas.
I don't have areas for you.
Hey, Mr. BOFA.
I don't know anything about it for now. I'll see you guys.
Bye-bye.
Oh, sir, please, is it on the class? Then I the 2 questions. Fine, go ahead. 2 hours.
Okay.
Hello, sir. You called me. Hello, sir. Hello.
Control the class.
He was just thanking you for helping him to control.
Yes, thanking you for helping him to control the class.